Point is a philosophical concept. A point, let us consider that the tip of the pen is a point. Now, if it is asked where this point lies, rather it's a difficult question, dear friends, until and unless we take some referral access. In 1637, the great philosopher and mathematician of France, Rene Descartes, he published a book, La Mathématique, in 1637, in which he had a try to locate the points in terms of coordinates like x, y, r, theta, etc. Okay, these are said to be the coordinates of the points. So the point be it in the space or be it on the plane, that way he could position the point or locate the point, and by that way he could establish the algebraical relation of the different geometrical figures like straight lines, like circles, any curvilinear line. This was expressed in the form of this algebraical form x, y, or theta, etc. And he could establish and he could solve the geometrical problems with the help of algebra. And that gave the birth of a new mathematical, tool that we call the analytical geometry. And this is our topic today. Okay, friends, I am A.K.D. Shah in your very own channel, Classes with I Learn. At this point of time, for the students of the junior standard, like 9, 10, 11, we will be more interested about solving this analytical geometrical problems with the two-dimensional axis, and that too, with the Cartesian coordinates of x, y. This r theta is the polar coordinates, and there are some other form of the coordinates also. Now for that, we have to take some two straight lines. One is x, o, x dash, and y, o, y dash. If these two axes leans each other at an angle of alpha, where alpha not equals to 90 degree, we call it the oblique axis. But here we will be interested to discuss with this thing, that which is that when x, o, x dash and y, o, y dash, these two axes stands on each other or cut each other orthogonally, that is the angle between them is 90 degree. Okay. So this xo, x dash is called to be the x-axis, and yo, y dash is said to be the y-axis. And in the SEU, means the anti-clockwise direction, we name these quadrants as first quadrant, second quadrant, third quadrant, and the fourth quadrant. There is an admitted convention of sign to place the points, like for the first quadrant, we place this plus, that is for the x is plus and y is plus. For the second quadrant, the x is minus, y is plus. For the third quadrant, the x is minus and y is minus. And for the fourth quadrant, x is plus and y is minus. Take for example, we have taken a point P, of whose the coordinates are x, y. This is an order pair. You cannot distort it, X is standing for the abscissa and y for the ordinate. Here you see, if we drop a perpendicular PM onto the x-axis, then this OM, the length OM, is said to be the x coordinate or abscissa of the point P, and MP, this is the y coordinate, or we call it ordinate of the point P. Now you have to take note that a point on the y-axis has got an abscissa of 0, a point on the x-axis has ordinate 0, the origin O has the coordinate 0, 0, and equation of the x-axis is y equals to 0, and equation of the y-axis is x is equal to 0. Now, let us take this coordinate axis xo, x dash and yo, y dash, and let us position 2 points, P and Q, of whose the coordinates are x1, y1 and x2, y2. Okay, and what do we want to find out? We want to find out the distance between the P and Q, that is PQ. This is our problem. Okay, now you see, if you drop a perpendicular PM onto the x-axis and QR, a perpendicular dropped on the x-axis, and you drop another perpendicular from P to QR, that is PN, then by simply this thing you can find out the distance between these 2 points P and Q, of whose the coordinates are known. So you see, from the figure and from the concept of the coordinates, OM is x1, OR is x2, and PM is y1 and QR is y2. So therefore, by simple geometry, that M1 is equal to OR minus OM, that is x2 minus x1, that equals to Pn, and Q1 is equal to QR minus NR, that equals to QR minus PM, and that equals to y2 minus y1. Now from this triangle, PQN, which is a right angle triangle, okay, you see from the Pythagoras theorem that PQ is equal to under root PR square plus QR square. Simply place the value and you get the answer. So this will be under root x2 minus x1 whole square plus y2 minus y1 whole square. Now we can have the case analysis. If the one point is O, that is the origin, and your point is P, which has got the coordinate of x and y, are simply derived coordinates. So OP is equal to under root x minus 0 whole square plus y minus 0 whole square, that comes down to x square plus y square. Now you should ask to know, so what is the application of it? Why will we be doing this coordinate geometry or the analytical geometry? We can have the, we have the lots of application for it. Like to check whether the points are collinear. 3 points are there, whether they are collinear or the vertices of an isosceles, equilateral or a scalene triangle. If there are 4 points, whether the 4 points are the vertices of a square, a rhombus, a rectangle, a parallelogram or a trapezium. Now let us take some 2 illustrative examples. Here is question number 1. The question is, find the distance between the points P minus 2 and Q 8 minus 2. So it's easy. The modulus of PQ is a distance, it cannot be negative. So this is the formula I have applied, and it comes down to 100 root over 16, root over 116, that is units of length. Let the example number 2 be this. So the points 3, 4, 8 minus 6 and 13, 9 are the vertices of a right angle triangle. Okay, you have to prove it. Now let the points be P this, Q this and R this. Therefore, by the distance formula, PQ square is equal to 8 minus 3 whole square plus minus 6 minus 4 whole square is equal to 125. This way you can find out QR square is equal to 250 and the PR square is equal to 125. Now if you take this, the algebra, QR square is equal to PQ square plus PR square, when 125 plus 125 becomes equal to 250. So you can recall that from the Pythagoras theorem we can say that the square on the hypotenuse is equal to the sum of the squares of the other 2 sides. So PQ1 is a right angle triangle. Now let us take another example. The question is, if the point xy is equidistant from the points a plus b, comma b minus a and a minus b, comma a plus b, then prove that bx is equal to ay. This is your question. So let us consider the point P to be xy and the other 2 points a plus b minus b, b minus bm, and n is a minus b and a plus b are the 2 points. Now by problem, P is equidistant from these 2 points m and n, therefore Pm is equal to Pn. You can square it. Pn square equals to Pn square. That is, this way you are overcoming the difficulty of the root. So x minus a plus b whole square plus y minus b minus a whole square is equal to this side. Now you are transposing it. The x side is drawn here and the y side is drawn there. You are transposing. Now simple calculation this way, if you go on calculating, finally you get that 4ab plus 2x into a minus b. The formula I have used, a plus b whole square minus a minus b whole square is equal to 4ab. In your class 6, 7 days we have done it, and this is that. So this way you get finally minus 4bx is equal to minus 4ay, and this way finally we reach that bx is equal to ay, and that has been proved. Now this is another question which is at the standard of the competitive exams like GMains, or G advanced or NDA. This is a type of question at the level of that. A difficulty level is somewhat more. Now what is the question? If P is a t square to a is a point, Q another point a by t square minus 2a by t, and S is another point a naught, be any 3 points, then you have to show that 1 by SP plus 1 by SQ is independent of T. What does it mean? Means in the final run, when you add this 1 by SP plus 1 by SQ, the expression that you get, there will be no T. Let us prove it. Now you know, by the distance formula, SP is equal to this, a simple one, a whole into 1 minus t square is whole square plus minus 2at whole square. Likewise, SQ is equal to under root this plus this whole square. Okay, now if you simplify this, then SP becomes, you just simplify. Here we have used the formula a minus b whole square plus a minus b square plus 4b square, you know, that equals to a plus b whole square. We have used that formula, right? A minus b whole square plus 4ab, that becomes a plus b whole square formula that we have used here. So here it is a whole into 1 minus 1 plus t square square, and that equals to a into 1 plus t square. Likewise, SQ from here, from this expression, you get SQ is equal to a, take out common, it will be under root 1 minus 1 by t square plus 4 by t square. Once again we are using the same formula which culminates to a whole into 1 plus 1 by t square square. So that is this. So you got SP and you got SQ. Then why don't you place it here? Therefore 1 by SP plus 1 by SQ, that equals to 1 by a into 1 plus t square plus 1 by a whole into 1 plus t square. Simplify it. This will be t square plus 1 or 1 plus t square. T square will go to the numerator. So that way, you know, the denominator becomes equals to a whole into 1 plus t square, and the numerator becomes 1 plus t square. Then in the numerator 1 plus t square and the denominator 1 plus t square cancels out, and it becomes 1 by a. And naturally it is independent of t. 1 by a, this has got no t in it. Okay. So this was all that were in our this class of analytical geometry part 1. Now friends, if you like my classes, then I will request you to put a like, share, subscribe, and you know, keep up with me. You can press the bell icon, because I will be continually going on uploading this type of videos which I think will be beneficial for my students. This is all for today. Thank you all.